Here's a beautiful geometric puzzle. See if you can figure it out before I reveal the answer. Put a point P anywhere inside a triangle and drop perpendiculars to all three sides. Let's call their lengths x, y, and z. Where should we place P to make the product x times y times z as large as possible? I'll wait. Your first instinct is probably the incenter, where all three lengths are equal. And that would work, except the lengths depend on each other. If you move P closer to one side, that perpendicular gets shorter while the others get longer. We need to find how they're connected, and that means thinking about area. Look at what happens when we connect P to the three corners. The triangle splits into three smaller ones. The area of the bottom one is 1/2 a times x, the right one is 1/2 b times y, and the left is 1/2 c times z. Add them all up, and you must get the total area of the big triangle. Now look, we want to maximize x times y times z, but the side lengths are fixed constants, so if we multiply a, b, and c into the product, the location of the maximum doesn't change. We want to maximize ax times by times cz, subject to their sum being constant. Remember the AMGM inequality from algebra class. It says the sum of three positive numbers is always bounded from below by 3 times their geometric mean. This inequality tells us the maximum product happens exactly when the three terms are perfectly equal. So a sex equals by literally equals cz. What does this geometric condition actually mean? Look closely at those terms. They are exactly twice the areas of our three smaller triangles. So to maximize the product, the three subtriangles must have exactly the same area. There is only one point inside a triangle that divides it into three equal areas, and that point is the centroid, where the three medians intersect, not the incenter, the centroid. And this makes sense because the centroid balances the distance to all three sides. So the answer is the centroid. The key was turning a problem about lengths into a problem about areas, and letting the AMGM inequality do the heavy lifting for us. This same trick shows up constantly in physics and optimization. If you enjoyed this, like and subscribe for more.